In this video, we'll discuss continuity and differentiability, right? And let's give the definition first or recall the definition first. So we are given a function, right? We always discuss function. Y equal to the function is the function we are discussing. And we are given a number also. A here is inside the domain of F, right? So we say that F here is continuous at A. If what happens if as x goes to A, f of x equal to f of A, right? And okay, so that's a function being continuous at a point, right? We say that a function here is a differentiable at A, right? That's a different name for the duality exist, right? So just if what happens if f prime of A here exists as a finite number. So if f prime of A, the special limit exists as a finite number, we call that differentiable, right? So which means this is equivalent to say that as h goes 0, f of A plus h minus f of A over h. If this limit exists as a finite number, which then our function is differentiable, right? So let's try to compare them first. Then we will give an example of some function may not be differentiable. So let's see that. Let's write down this fact, right? Fact here is being differentiable is better than being continuous, right? So we say that if stronger, right? If f is differentiable at A, so what's the meaning of that is the duality exists, right? Then the function is continuous. Then f is continuous. Differentiability implies continuity, right? Continuous at A, right? Okay, let me give you a very short justification, right? So this thing here, right, this limit is equivalent to say that as x goes to A here, f of x minus f of A, this has to be 0, right? Because the second is constant. So these two are equivalent. So if you want to assume this all this, right? This f of x minus f of A, we have two definitions for the duality. One is involving h, the other one involving x and A, right? So how do you show this is true using this exists as a finite number? This is basically how to prove such a fact, right? Let's write down a very short justification, right? So we know this is a finite number. This second limit is a finite number, but we don't know this is 0 or not, right? We want to show this is 0 or not. Let's try to evaluate it, right? So this is our assumption. This is the conclusion we wish to reach, right? Let's try to evaluate f x goes to A, f of x minus a f of A here, right? So, okay, let's try to make the connection, right? And clearly, the connection is easy, right? So this is same as x goes to A here, f of x minus f of A over x minus A times x minus A. For sure, they are same, right? You can see that the second factor here goes to 0. if the first factor goes to infinity, you don't know anything. But by our assumption, the first factor go to a finite number. So any finite number times 0 is 0. So this has to be 0. So that's the reason why differentiability implies function is continuous, right? Okay, now let's see another example. Right? Our function here is f of x equal to the absolute value of x, right? That's easy. So we want to ask is f prime of 0, okay, does exist, right? Find it if it exists, right? We want to evaluate f prime 0, right? That's what we want to do. So in the same time, I try to sketch the graph of this function around 0. So that's a corner, right? Right side, left side. So that's our 0 here, right? So let's see what happens at 0, right? So let's try to do that. So by our definition here, f prime of 0, if this exists, this should equal to as x goes 0, the absolute value of x minus the absolute value of 0 over x. Right, that's what we are looking for. If this is a finite number, then the utility exists. If this doesn't exist, then f prime of 0 doesn't exist, right? So let's try to do that. And you can see that we have 4 different ways to evaluate a limit. And this one here, we can use the left and right limit because the definition of absolute value, we have to divide it into 2 parts, right? So we know that as x goes 0 on the right side, so x goes 0 on the right side implies x is greater than 0, implies this is true, right? And so x over the absolute value of x over x is same as the limit as x goes 0 from right side, x over x. So this is 1. Now let's look at left side. X goes 0 on the left side. And when you have x goes 0 from left side, we know that x has to be less than 0. We know that in this case, the absolute value of x is negative x, right? So this is equal to as x goes 0 from left side, negative x over x. So this is negative 1. So the left limit is negative 1. Right limit is 1. They are different. So f prime of 0 does not exist, right? So which means this is the meaning of that is does not exist. And so which means whenever you have a corner, something like this, in the graph of this function, the function is not differentiable, right? So derivative doesn't exist. F is not differentiable, differentiable at 0, right? And so also if you have some function not continuous, for example, you have a hole or a corner or a gap, or sometimes you get a vertical tangent line, right? The function is not differentiable. So that's the case is when the function is not differentiable.